Hello, everybody. Welcome to this week's lesson. So this video is for you if you were not able to attend one of our live Zoom lessons on Monday or Tuesday, or if you just wanted to revisit that lesson. So over the last couple of weeks, we've been working on two-dimensional geometry. And this week we are changing gears a little bit. We're going to cover functions. So I wanted to make sure that during the month of June, as we're kind of wrapping up our spring/summer period here, we have time to tackle both the geometry and the functions because those are big topics on the GED test, and there's a lot to them. They could be a little tricky. So moving on to functions this week, and specifically we're going to be focusing on understanding what a function is, as well as being able to identify a function. So the goal is by the end of this week, you will be able to plot points on the coordinate plane, state the definition of a function, represent and identify a function in a table or graph as having exactly one output for each input, and finally, use the vertical line test to identify a function. So as we work on this lesson, you definitely want to have a pencil and paper out in front of you so that you can take notes. Anytime I ask a question or put an example up on the screen, I'd encourage you to pause the video to give yourself a chance to answer the question before I answer it for you. You might want to have a calculator in front of you. You might not need it a ton during this lesson, but you can have one in front of you if you'd like. And I would also encourage you to have your formula sheet in front of you, just because it's always good to have your GED formula sheet in front of you. All right, so we're going to start off here by talking about the coordinate plane. So when we talk about functions, we talk about graphing, we make a lot of use of the coordinate plane. The coordinate plane is a system that we have in math for describing the locations of stuff. So usually we mean the location of what we call points. So if you've ever used GPS coordinates, this is a very similar idea, or if you've ever looked at a map in an atlas, this is also a very similar system for giving specific locations of points. So the coordinate plane is a two-dimensional surface, so a flat surface, with an x-axis and a y-axis. So let's talk about that in a little more detail. This word plane should sound familiar to you from our geometry lessons. We talked about plane figures. So plane figures were flat shapes. Now that word plane is showing up here again, and it still means the same thing. It means a flat surface or a flat shape. So we're talking about a flat surface with an x-axis and a y-axis. These two axes, so the plural of axis is axes, these two axes are number lines. So we have a horizontal axis, a horizontal number line, and we have a vertical axis, a vertical number line. The horizontal axis is almost always going to be called the x-axis, and the vertical axis or the vertical number line is almost always going to be called the y-axis. There's no particular reason why we choose the letters X and Y. It's just sort of historically done that way since the person who developed the system made that choice. So we just decided to give them the names x-axis and y-axis. So note here that these two axes, these two number lines, they meet at the center. And at the center here is where both number lines have the value of 0. This center point, this point on both of the number lines where they're both equal to 0 is known as the origin. So because it's this central point, it has its own special name. It's called the origin. Okay. So I said the purpose of the coordinate plane was to allow us to give locations for points. So to describe the location of a point on the coordinate plane, we use two pieces of information. So we tell where the point lies along the x-axis, and then we also tell where the point lies along the y-axis. So every point has two coordinates, and we call this pair of coordinates, these two coordinates, we call them the coordinate pair. So every point's location is given by its coordinate pair. And that's usually written in this format. So we have parentheses around the two numbers. We give the x coordinate first, and we give the y coordinate second. So it goes in alphabetical order, right? X first, y second. All right, so let's try an example here. I've placed a red point on this coordinate plane. And we're gonna give the coordinates of this point. So when I look at this point, if I look to see where it's lined up along the x-axis, well, I can see it's lined up with 1 along the x-axis. So that means the x coordinate is going to be 1. I'm going to fill that in. And then when I look to see where it's lined up along the y-axis, it is lined up with 2. So the coordinates of this red point would be 1, 2. So let's say I asked you, hey, what are the coordinates of this red point? You would say the coordinates are 1, 2. Okay, so we're gonna get some more practice here with identifying the coordinate pairs. So what I would do if I were you is I would pause the video right now and I would try filling in the coordinates for each of these 5 points. Go ahead and do that, and then when you're ready, you can resume the video, and I'm gonna walk through each of these points. Okay, so we're gonna start with the yellow point right in the middle here. So this yellow point is actually sitting at the origin, sitting at the center of our two axes. So because it's right at the origin, we see that that means it's at 0 on the x-axis and it's also at 0 on the y-axis. So the coordinates of this point is going to be 0, 0. All right, now on to the red point. So this red point is lined up with 1 along the x-axis. So I'm going to put 1 for the x-coordinate. And it's lined up with 3 along the y-axis. So I'm going to put 3 for the y-coordinate. So this point, this red point, is at 1, 3. All right, now on to the purple. So the purple point is lined up with 2 on the x-axis. And it is lined up with -1 on the y-axis. So this purple point is at 2, -1. Next, we've got this blue point. So this blue point is lined up with 0 on the x-axis. Lined up with 0 along the x-axis. And then it is lined up with -2 on the y-axis. So this blue point is at 0, -2. And then finally, our green point is lined up with the -4 on the x-axis and is lined up with 5 on the y-axis. So the coordinates will be -4, 5. Okay, so in the next slide here, we're going to get some practice doing the opposite. So here I've given you the coordinates for 5 points. And what we're going to do is we're going to practice taking those points and plotting them on the graph. Okay, so again, this would be a place to pause the video, and then I would copy down this picture of the coordinate plane, make your own little coordinate plane on your paper. And then see if you can plot each of these points. And when you're ready, come back to the video. All right, so let's start here with point A. Point A is at 0, 5. So, right, I know 0 is my x coordinate, and I know 5 is my y coordinate. So I'm going to go to 0 on the x-axis, and then I'm going to go up to 5 on the y-axis. So the point 0, 5 is going to be right here. This is point A. Oftentimes when we are talking about points on the coordinate plane, they'll be labeled just like this, where they're given a capital letter as a name. All right, let's go to point B. So point B is at -2, 3. So I'm going to start off with my x coordinate. I'm going to go over to -2, and then I'm going to go up to 3 on the y-axis. So it's going to be this point right here. This point is aligned with -2 on the x-axis and 3 on the y-axis. So this is point B. And point C is at 4, -1. So I'm going to go over to 4 on the x-axis, and then I'm going to go down to -1 on the y-axis. The point C will be right here. And I'll put the label there so we know what it is. All right, and up next is point D. So point D is at -5, -5. So I'm going to start by going over to -5 on the x-axis, and then I'm going to go down to -5 on the y-axis. So point D is right here, just happens to be at the corner. And then finally point E has coordinates 1, 1. So I'm going to go over to 1 on the x-axis and then up to 1 on the y-axis. So we've got this point right here, point E. Now, if you'd like some more practice with understanding the coordinate plane or plotting points, I'd really recommend that you check out the online learning links post from this week on Google Classroom. I'm going to be providing links to a few different videos that just talk more about the topics we're touching on this week and give you opportunities for extra practice, because I know some of this might be totally unfamiliar to some of you, or you might just be interested in getting a little more practice and explanation. So definitely check the online learning links post out. It'll be in the topic for this week on Google Classroom. All right. So we just learned a little bit about the coordinate plane, which is a system we have for locating points in space. Now we're going to talk about functions. So functions, again, it might be something that you've heard of before or worked with before, or it might be totally new. The main thing I would recommend as we dive into functions is that you keep an open mind and you keep your pencil at the ready, okay? Sometimes people get a little freaked out by functions just because it can seem a little bit different from math you may have done before. And it is a little bit strange, but just because it's strange doesn't mean it's difficult or impossible to get your head around. So just keep an open mind and come along on this journey with me. So a function is a relationship between an input and an output where each input has exactly one output. Okay, so that's the basic definition of a function. So if we were to kind of get an even bigger picture on what a function is we could just say that a function is a relationship between two things. So oftentimes in life, as well as in math, we are interested in talking about the relationships between things. You know, anytime you talk about cause and effect, or anytime you give reasons for something, that means you're talking about relationships between different things, different ideas. So a function is like a mathematical tool we have for describing a relationship. So there are multiple different ways to represent a function or represent this special type of relationship, but a function always has three main components. So we can think of a function as consisting of the input, so what we put into the function. Then we can think about the actual relationship itself. And then finally, we've got the output. So we've got the input, we've got the output, and then we've got the relationship kind of sitting in the middle here. One way that you might see functions described is you might see them described as being like machines, kind of like a mathematical machine. I like to use the example of like a toaster. So if you think about a toaster as being a pretty simple machine that a lot of us have in our houses. So we've got a toaster sitting on our counter here. Toaster sitting on our counter. And then what do we put into our toaster? What's the input that we give our toaster? Well, the input we give our toaster is a piece of bread, right? So we put one piece of bread into our toaster. And then what's the output that we get from our toaster, right? We put the one piece of bread in, we wait a few minutes for the machine to do its thing. And then what's the output or the result that we get? Well, the output that we get is we get one piece of toast, right? So if we put one piece of bread in, we get one piece of toast out. That is a perfect example of a function. So it's this relationship between input and output where each input has exactly one output. If you put one piece of bread into your toaster and then you got two pieces of toast out of your toaster, well then congratulations, you have a magic toaster. And that toaster is no longer a function. So a function is a special relationship between input and output where each input has exactly one output. Okay, so we're going to dig in a little deeper to this idea of input and output. We're going to talk about them as variables. So in math, a variable is an unknown or a changing quantity or changing number. And it's usually represented by a lowercase letter. Again, there's not any particular reason for that. It's just, we have to pick something, we have to choose some symbol, and historically, people have just chosen to use lowercase letters. So a variable is an unknown or a changing quantity. If you have done any algebra before, when I talk with folks, it seems like one of the things that really sticks out to them is that, all of a sudden when you transition to working in algebra and math, all of a sudden like the paper is full of letters instead of just numbers. And those letters are variables. Those letters are just placeholders for unknown or changing quantities. So if we return to this idea of functions where it's a relationship between input and output, well, those inputs and outputs are two variables. They are, each of them is an unknown or a potentially changing quantity, okay? So the input variable can also be known as the independent variable. Those are just two different names for the same thing. And oftentimes they're labeled as X. So oftentimes we use the letter X to represent our input in math. And then the output variable is also known as the dependent variable. And it is often labeled as Y, or you might see it labeled in this way. So you might see it labeled as f of x. That's how we would read that. So we would say f of x, and it's really just short for a function of x. So I know this might be new notation for you, but remember we're keeping an open mind and just accepting that there might be a lot of new information here, okay? So again, make sure you got your pencil and paper out in front of you. Make sure you're writing all this new information down if you can. Okay, so we've got our input variable, or X, and we've got our output variable, or our Y. So at the bottom of the page here, I have an example for you. So I think that might make this a little bit easier to understand what I'm talking about. So the example is, I just picked something. We're talking about relationships here. I just came up with an example of a relationship. So the example here is that Robin earns $15 per hour. The equation below represents her total earnings based on the number of hours she works. And then I have this equation right here. So notice this example is not a question. There's nothing for you to solve here. I'm merely giving you an example of the kind of input-output relationship that I'm talking about. So this example starts off with a verbal or a word description of the relationship. It is telling us about the relationship between the amount of time that Robin puts into her job and the amount of money that she gets out of her job. And then down here, we have basically the same information, but just conveyed using the mathematical language of equations. So this equation is basically just shorthand. It's a shorter way of writing out that verbal description that we started with. And so again, we've got this relationship between input. So the input would be the X, or we can think of it as the number of hours that she puts into her job, the number of hours that she works. Right, she inputs the number of hours that she needs to into her job, into the function here. And what she gets is a result. She gets a result of money that she's paid. So the output, or the result of this, is her total earnings, the amount that she's paid. So that would be the Y. And the Y stands for the amount of money that she earns. So again, this function is not telling us a specific amount of money that she's going to earn. What it's doing is it's kind of just describing for us the relationship between the amount of time that she puts in and the amount of money that she gets out of it. And we could use this description to help us calculate different total earnings based on the amount of time she puts in, right? So let's say she puts in 1 hour of work, right? Let's say she works for 1 hour. Well, based on our function, based on the relationship between time and earnings, we know that the amount of money she's going to earn is going to be $15 per hour, $15 per hour, times the number of hours that she's worked. So if she worked 1 hour, that's going to give us an output of $15. And we could do that same calculation for any amount of time. So if she worked for 2 hours, she would earn $30 and so on. So this verbal description, as well as this equation, they both give us the information we need to understand the relationship between the amount of time Robin puts into her job and what her earnings are. Okay, so on the last page, I used that word equation a few times. An equation is a mathematical statement that two things are equal. So basically, anytime you are using an equal sign, that means you've got an equation. So an equation is typically made up of numbers. So it could have numbers in it. It could have variables, right? So those letters that stand for unknown or changing amounts. It will usually have operations in it. So operations being what we do with numbers. So adding, subtracting, multiplying, dividing, exponents, roots, all that good stuff. And then also an equal sign, right? So because an equation means that two things are equal, equations always have equal signs. So equations can be like the simplest thing you can think of. So I could have the equation 1 = 1. You might ask yourself, why did I bother even writing that down? Because it seems so obvious, but it's a true statement, right? It's true that 1 does equal 1. Because I've got that equal sign in there, it means it's an equation. Or equations could get really complicated. I could have something long. If you look at your formula sheet, so if you look at your GED math formula sheet, you see on there we've got some equations that are a little bit more complicated. So, right, our formula or our equation for the area of a circle is that A equals pi times the radius of the circle squared. Right? So we've got this equal sign here. That means it's an equation. And this equation is telling us about the relationship between area of a circle and the measurement of its radius. Okay, so let's return to our example about Robin and the amount of money she earns. Right? So again, this equation here is one way of representing the relationship between the amount of time she puts in and the amount of money she gets out of her work. We've got the equal sign there. We've got our independent or input variable X. We've got our dependent or output variable Y. And then in order to calculate Y, in order to get that output, what we do is we multiply our hours, the number of hours we work, by $15 per hour. So again, this equation is just like shorthand for calculating her total earnings. Okay, let's move on here. So you mentioned a few screens ago that there are multiple different ways to represent functions, right? A function is just a relationship between two things. So there's a few different ways we can show or describe that relationship, and we've already touched on two of them. So remember that a function is a special relationship between an input variable and an output variable, where each input has exactly one output. Right? That's the definition of a function. It's the special type of relationship. And we have four main ways to show or describe these relationships. So one way we've already seen, and that's verbally or using words. So in our example with Robin, right here was a verbal description of the relationship between the amount of time she puts in and the amount of money she gets out. We can also represent a function algebraically or using an equation. And again, we already saw that in our example with Robin. So we could choose to use our mathematical shorthand. We could choose to use an equation to represent a function. And now most of the rest of the lesson today is going to deal with these last two ways of representing a function. So we're going to talk about graphical representations of functions. So that's a visual or a picture representation, and also numerical representations of functions where we're making a list of numbers or a list of values. Okay, so returning to our example with Robin, we have already seen the verbal description of the function. We've seen the algebraic description of the function. Now we're going to see also the numeric, right? That was our third way to represent a function, a numerical representation. So this is a numeric representation. And then we've also got a graphic representation or a visual representation here. So let's first talk about the numeric representation. When we say we've got a numeric representation of a function, usually it's going to take the form of a table like we have here. It might also be just a list of values, which we'll see later. But what we're really doing is we're creating a list of example numbers that tell us about the relationship between input and output. So what I've done here is I have chosen just a few example values of how much time she may have put into her job. And then I'm showing the corresponding output value, so the corresponding amount of money that she would have earned for that time. So I started with the simplest thing she could have done, which would be to put in 0 hours, right? So if Robin works for 0 hours, she's gonna make 0 money. That's just the way the world works, right? And then if she works for 1 hour, well, she gets $15 an hour. She works for 1 hour. That means she's going to earn $15. So the input is 1, then the output's going to be 15. If she works for 2 hours, 2 hours at $15 an hour, her output or her resulted earnings is going to be $30. She works for 3 hours, right? 3 hours times $15 an hour would be $45 for her earnings or her output. And then if she works for 4 hours, she'll make $60. And again, I just chose some example inputs here just to help you get an idea of this relationship between input and output. We could really choose any value here for input. So let's say she works, let's say in 1 week, she actually ends up working 37.5 hours, so 37.5 hours. And she wants to know how much money is that going to give me? So again, ignore, we're not dealing with taxes at all in this situation. It's very simple. She gets $15 an hour. We're not worrying about any deductions or taxes. So if she works for 37.5 hours at $15 an hour, that's going to give her earnings of $562.50. So if she works for 37.5 hours, she'll make $562.50. So again, the numeric representation or the table representation just gives us a list of example inputs and outputs for this function. And then finally, we've got our graphic or visual representation of the function here. So that's going to involve using the coordinate plane, right? The coordinate plane has this X and Y axes that help us locate points on the plane. So what I've got here is I've got a visual representation of this relationship between hours. So along the X-axis, I've got our input, which is hours or time. And then along the Y-axis, we've got her earnings, right? The amount of money that she's going to earn in dollars. So we'll call that earnings. So notice one thing, you might notice one thing here is that I cropped away the negative portions of the X and Y axis, right? So extending in this direction, the X axis continues, it would be like -1, -2, -3, blah, 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 blah. And then if we extend our Y axis down, we also have our negative Y values. I cropped those away because for this particular situation, negative numbers don't really make sense, right? It's not possible for Robin to put negative hours into her job. She might put 0 hours, but she can't put -2 hours of work in. And then same thing for money. She's not going to be getting negative money for her job. The lowest amount of money she could possibly get is 0. So I just cropped those out of this picture here because they're not relevant for this problem. Okay, let's take a look at what is relevant here. So notice that this graph, this red line here, corresponds to the information we already know. So we already know, thinking about our equation or our table, that if Robin works for 0 hours, she's going to make $0. So the point 0, 0 lies along our graph, along our red line here. We also know that if she works for 1 hour, she's going to make $15. That's why we've got this point 115 that lies along our graph. And we know that if she works for 2 hours, she's going to make $30. So we've got this point that lies at 230. And so you'll see, right, that for each of the hours along here, so 3 hours, 4 hours, and so on, that point corresponds to the money, the amount of money that she gets for that time, right? So 3 hours was $45, so we have the point 345. 4 hours gave her $60, so we have this point 460. And then just because I had some more room on my graph here, I was able to continue it further. So right, for 5 hours, she would make $75. For 6 hours, she would make $90. 7 hours, she would make 105. For 8 hours, she'd make 120. And then if we had even more space, we could continue this graph if we wanted to. Right, this line will keep going forever in this direction, right? The amount of money that she makes will keep going up and up and up as the amount of time also goes up and up and up. And this is instead of just being a series of points, right? This is a continuous line because she could also work parts of an hour, right? So let's say Robin worked 1.5 hours, 1.5 hours. Well, that would correspond to an amount of money between $15 and $30, right? It would actually be, let me just make sure I'm doing this math right here. So, right, 15 times 1.5, right, it would be $22.50 would be her earnings. Let's say she worked 2.25 hours. 2.25 hours, so 2.25 hours. She would earn $33.75. So every single point along this line represents some coordinate pair of time and earnings. Right, and if I did extend this line up and up and up and up here, I would eventually get to the point 37.5 and $562.50, right? I would eventually get there if I had a really big screen to work with. All right, so again, I have not asked you to solve any particular question yet. All we've done is we have thought about the definition of a function, and we've looked at different ways that we can show or represent functions. So now we're going to get into some types of questions that you might encounter about functions. One of the types of questions you might encounter about functions on the GED test is where they ask you whether or not something is a function. Okay. So we're going to start off with looking at tables, so looking at numeric representations of relationships and determining whether or not they show us functions. So the key thing here is that we remember the definition of a function, right? A function is a special relation where there's exactly one output for each input. So exactly one output for each input. That's the key thing to remember here. So let's look at the first table. So we've got our input here and our output. Now this first table, take a look at each pair of numbers and make a prediction. Make a prediction, tell whether you think this is a function or is not a function. Okay, so this is a function. This first table here is a function. It's a function because when we look at each input value that's listed, so each x value that's listed, there is only one output for each of those inputs. So if we look at -2, -2 only shows up with -4 in our table. It doesn't show up with any other output. Same thing for -1. It only shows up with an output of -2. It doesn't show up with any other output. Same thing for 0. And same thing for 1. Now, if we take a look at our second table here, again, take a moment to predict whether or not you think this is a function. So this table is not a function. It is not a function because the input -2 corresponds to more than one output. So here we see -2 showing up 4 times. And instead of just going with -4 like it did in the last table, now it's going also with -2, it's going with 0, and it's going with 2. So we've got this one input, this one x value that corresponds to more than one output. That means it is not a function. All right, let's look at our third table here. So table number 3 is an example of something that is a function. So table 3 is showing a function. And that's for the same reason as it was in table 1. So the input of 1 goes with the output of 3. The input of 4.75 goes with the output of 6.75. The input of -2 goes with the output of 0. And then this may have thrown you off here because we see the same input again. So 1 is repeated here, but it's still going with the same output, right? Still going with 3. So the input of 1 only has one output. It only has the output of 3. So this is still a function. Now let's look at the final table here. So take a moment to predict whether or not you think this is a function. Okay, so table number 4 is not a function. not a function. And why is it not a function? Well, this table is almost exactly the same as table 3. If you look at the x and y values, they're almost exactly the same, except I made one change. And the change is that now the input of 1 has 2 different outputs. So 1 goes with 3, but now it also is going with -1. It has 2 different outputs. And that means that this is not a function. And by the way, when we say something is not a function, that doesn't mean that it's like wrong or bad or there was a mistake there. It just means it's a relation that's not a function. It doesn't fit the definition of a function. So it's still a perfectly good table, a perfectly good list of numbers. We just wouldn't call it a function. Okay. So on the page here, we've got 4 different examples. For each of these examples, I want you to answer the question, is it a function? So again, go ahead, pause the video and take a few minutes to answer each of these questions. And then resume the video when you're ready to hear the answers. So for number 1, when we look at each of these inputs, each of these inputs is only going with one output. Right, each input actually only shows up once. So that means it's definitely going to be a function. So we would say, yes, this is a function. For number 2, again, each input is only going with one output. Now, something that might have thrown you off here, you might have said, well, -5 is going to -5, but then also 6 is going to -5. That doesn't matter here. All that matters is each x value only goes with one y value, and that's true, right? So -5, the x value, -5, only goes with -5. It doesn't go with any other numbers. That's also true for 6, right? 6 only goes with -5. It doesn't go with any other numbers. If I added another line to this table, let's say I added another line like this. So now 6 is going with -5, but it's also going with +5. Now this is no longer a function. So if I get rid of that, if I get rid of my extra stuff here, then this table, as it's written, does show us a function. So we would say, yes, this is a function. All right, number 3. So number 3, we would say, no, this is not a function, because we see here that the input of 0 is going with 2 different outputs. And then same thing for the input of 1. It's going with 2 different outputs. So that means this is not a function. And then for number 4, so number 4 is still a list of values. I just listed them in a slightly different way. So instead of a table where we have an X column and a Y column, I've just given you a list of coordinate pairs, right? Those coordinate pairs we talked about at the beginning of the lesson. So we have a list of coordinate pairs. We could just as easily have organized this into a table, but I wanted you to see this different way of writing out the problem, because you might see this in a question. So a list of coordinate pairs, list of x values and y values. Is this a function? Yes. This list of coordinate pairs is showing us a function because each x value only shows up once, right? It only shows up with one y value. Okay, let's move on to the next one here. So we just got some practice with identifying functions when they're represented numerically as tables or lists. Now we're going to get some practice with identifying functions that are represented graphically, so represented visually or as a picture. And the way that we do that is with something called the vertical line test. The vertical line test is a quick visual check to see if a graph is showing a function or not. And the vertical line test, we didn't just pick vertical lines for no reason. There is a reason, and it all comes back to the definition of a function, right? The definition of a function tells us that each input has to have exactly one output. So each input must have exactly one output. Now, if we think about input and output in terms of a graph, right? Input corresponds to X, and output corresponds to Y. So on a graph, right, X is the horizontal direction, the horizontal axis, and Y is the vertical direction or the vertical axis. So if we look at the first graph here, look at the first graph, and let's focus on one point of this graph. So if I focus, when I say graph, I mean like the blue line, so not the axes, but the actual thing that we've plotted on the plane, so the blue curve here. So I just picked out this one particular point that lies along this blue curve. Now this point, it looks like it has an X value of 1. Oh, sorry, an X value of -1. And it also has a Y value of -1 at that same point. So at that red point I just put down, the X value looks like it's about -1, and the Y value is also, sorry, the Y value is 1. Just misspoke again. Sorry about that, guys. The Y value is 1, not -1. Okay. So when I ask myself if this is a function, right? I'm asking myself, does each input have exactly one output? Well, what would it look like if that wasn't the case? On this graph, that would mean that there's more than one Y value for an X value. So if we think about the X value of -1, let's say -1 also had a Y value of -2, let's say. So if we were looking at this as a table, we would look at this table and would be like, oh, that's definitely not a function because the input of -1 is going with 2 different outputs, right? That's a problem. Now on the graph, that would show up as points that are lined up vertically with each other, points that are lying along the same vertical line. So I just put that green point on the graph. That green point is the point -1, -2. And you can see, hopefully, that the red point and the green point are lined up vertically. And so that's where the vertical line test comes in. The vertical line test is a way for us to quickly visually check and see if we've got exactly one output for each input. So the way that we do the vertical line test, I'm gonna erase this extra stuff I just put on the graph. The way that we do the vertical line test is you can either actually write this on your paper or you can just visualize it in your head, is we imagine drawing a vertical line through the graph in multiple places. And the graph passes the vertical line test if we only intersect the graph at one point. So each time I drew a vertical line through this graph, I only intersected or crossed the graph one time. Right? You see each of these vertical lines only crosses the graph once. So we would say that this graph, graph number 1, passes the vertical line test, and that means it is a function. Okay, let's try that with graph number 2 here. So again, I'm going to draw some vertical lines through this blue graph. And I'm looking for the vertical lines to only cross my graph once. Okay. So I just crossed once. I crossed once. I crossed once. So you can see here that anywhere I draw a vertical line along this graph, I'm only ever going to intersect or cross the graph at a single point. So we would say that this graph passes the vertical line test, which means it is a function. So functions can come in all different shapes and sizes, right? A function isn't about being like a straight line or a curvy line or a series of points. It is about the special relationship between input and output. So even though graphs 1 and 2, they look very different, that's okay. They're just two different functions. Now let's look at graph number 3. So graph number 3, say I draw a vertical line through it. Now here, my vertical line has crossed the graph in 2 different points. And there's many places along this graph where if I draw a vertical line, it's going to cross the graph at more than 1 point. It's going to cross the graph at 2 points. So we would say that this graph fails the vertical line test, which means it is not a function. Okay, let's take a look at a few more examples of this. So for each of these graphs, A, B, and C, we're gonna perform the vertical line test. So go ahead and pause the video and give it a try your own, and then resume the video when you're ready to see the answers. So graph A, I just lost my mouse. Graph A, I can draw a vertical line anywhere through this graph, and it is only going to cross the graph at a single point. So remember, you could be like actually drawing these lines, or you might just be visualizing it in your head. Once you get the hang of it, you can probably just visualize it. Right? Just look at the graph and imagine those vertical lines. But I can draw a vertical line anywhere through this graph, and it's only going to cross at 1 point. So we would say, yes, this is a function. All right, for graph B, same thing. I can draw a vertical line anywhere through this blue graph, and it is only, the vertical line is only ever going to cross at a single point. So yes, this is a function. For graph C, if I draw a vertical line through this graph, through this circle, at many places along this graph, if I draw a vertical line, it's going to cross at 2 points, right? Not just 1 point, but 2 points, which means it fails the vertical line test. It is not a function. So no, it is not a function. Now again, that doesn't mean there's anything bad or wrong with this graph, right? This is a perfectly beautiful graph of a circle. It's just not a function. Okay, so we're going to end today with 3 practice problems. So these problems are similar to how the questions would appear on the actual GED test. All of these questions are going to involve identifying whether or not something is a function or thinking about the definition of a function. So question 1 says, without repeating one of the existing coordinate pairs, select 2 numbers that would make the following a function. So using the list, the blue list down at the bottom, you want to create a coordinate pair that you could add to the table that would make this a function. Okay, so there are many different ways that you could answer this question. There's many different correct answers. You are just looking to add a pair of x and y, or f of x, right? So that's another way of saying y. So a pair of x and y numbers that continues to allow this thing to be a function. So let's see, I could choose the number 3 as my input. And then that 3 could go with really any number I like. So let's pick 5. Could go with 5. And write 3 again. So it goes with 5. Right? If I look down here at my list of input values, it is still true that each input is only going with 1 output. So my choice of 3 and 5 is a perfectly good choice. You could also choose, is there anything else you could choose actually? I think that actually might be it. So yeah, 3 and 5 would work here. Now you could also, of course, repeat coordinate pairs that are already there. However, they're asking you not to repeat the coordinate pairs. So 3 and 5 would work here. All right, let's take a look at number 2. So it says determine whether tables A, B, and C represent functions. All right, so let's start with table A. We look down the values in table A. We're checking to make sure that each input only goes with 1 output. And that is true for table A. So table A, we would say, yep, this is a function. Now you might get a little concerned because the input 3 shows up twice here. However, it shows up with the same output both times. So that's still okay. All right, now table B, we look down our list of inputs. I see that all of the inputs are different. So that tells us, yes, this is a function because each input only goes with 1 output, right? It's never something different. All right, and then table C. I look down my list of inputs. Now this is all the same input, right? It's 5 every single time. And now we've got a problem because 5, the input of 5 is going with 5 different outputs. So that means no, this is not a function. One more thing to notice here in this problem, they're using different letters for input and output. Again, that's fine. Remember, the letters are just standing in for unknown or changing quantities. So you You really can choose any letter you want to. X and Y are the most common, but you might sometimes see different letters used. Okay, and our last practice problem, we want to identify which of the following graphs represent functions. So take a moment to look through these 4 graphs and make your decisions. Okay, so I'm going to use the vertical line test on each of these 4 graphs. I'm going to label them 1, 2, 3, and 4. So graphs that are functions, that would be graphs 2 and 3. Graphs 2 and 3 are functions. Graphs 1 and 4 are not functions. So graphs 1 and 4 both fail the vertical line test. If I try drawing some vertical lines through graph number 1, I can see my vertical lines are going to be crossing in more than one point on the graph. Same thing for graph number 4. If I draw a vertical line through my graph, it's actually going to cross in 4 different spots. Right, so it's definitely failing that vertical line test, so it's not a function. So the correct answer here would be graphs 2 and 3. Again, right, functions can come in all different shapes and sizes. Graph number 2, we've got this horizontal line here. Graph number 3, we've got this sort of mountain looking thing that I drew. That's fine, they can be very different as long as they pass that vertical line test. All right, everybody. Well, thank you for making it to the end of the lesson here. I hope you feel like you've got just a little bit of a better understanding about what a function is and what they look like on the page. Again, this week, all of the assignments are going to be giving you practice with identifying functions, thinking about the definition of functions, as well as working with the coordinate plane. So you're going to have, for assignments, you're going to have your problem of the day for June 8th. You're going to have your worksheet Wednesday. You're going to have your problem of the day for June 12th. And I'm also going to be posting your vocabulary quiz on Tuesday. Okay, so look out for those assignments getting posted to the Google Classroom. And the vocabulary list is already up there. So go ahead and check out the intro post for this week on the Google Classroom. And if you do have any questions, definitely let me know. You can come to Zoom tutoring hours on Wednesday or Thursday, or you can always drop me a message. I hope you're all having a good week. Take care. Bye.